Shock response analysis of a cylindrical column. This tutorial explains how to perform shock response analysis using feast. This tutorial also explains how to define rigid links in feast models. Since the model is circular in cross-section, symmetric boundary conditions is used. The shock data is supplied as frequency versus acceleration table. This has to be stored in an Excel sheet in CSV format before starting the analysis. The material properties are Young's modulus 200 GPa, Poisson's ratio 0.3 and density 7800 kg per meter cube. In this model, we are going to create brick element. We are creating the brick element by extruding the shell element. For creating the shell element, you need a surface. For that, first turn on the grid view. Create a key point using XYZ. Create a key point at 0, 0, 0. Create key point at 50, 0, 0. Hundred 0, 0, 0, 50, 0, and 0, 100, 0. You have to create the curve. For that, go to Geometry, Curve, Create, Arc 2P. Click Snap to Point option. Select the endpoints of the curve. Enter the radius value as 50. Select the reference point on the grid. Turn on Snap to Grid option. Click Apply. The curve will be created. Now again, turn on Snap to Point option. Click the endpoints of the second curve. Enter the radius value as 100. Select a reference point. Click Apply. Now you have to create the surface by loft option using these two curves. For that, go to Surface, Loft, pick the two curves created, click Apply. The surface will be created between these two curves. Now you have to mesh the surface. For that, go to Mesh, FE Mesh, Quad, pick the surface, enter the initial size by picking 2 points on the edge of the surface or by directly entering the value in the parameter box. Click on Divisions. Adjust the number of divisions on each side by left clicking or right clicking. Select Mapped Meshing. Click Apply. The quad elements will be created. Now erase the surface using Erase Surface option. Erase the curves. Erase the key points. Enter all. It will erase all the key points from the window. Now you have to create the brick elements by Mesh, Element, Create, Extrude. Select all the element IDs. You can use the type option. Pick type, pick on any shell element. All the shell elements will be selected. Now in extrude vector value, enter extrude vector as 0, 0, minus 200, It will be extruded in the negative Z direction. Enter the number of segment as 10. Click apply. Brick element will be created. Now you have to copy and mirror these elements so that it will form a semicircular shape. For that, go to Mesh, Element, Copy, Mirror. Select all the elements. Select the plane with respect to which all the elements should be mirrored. A point on the plane about which the element should be mirrored. Click apply. All the elements will be mirrored and a semicircular shape will be created. Now, if you go to View and tick Free Edges, you can see a free edge at the center of the model. It means duplicate nodes are present at that location. In order to remove the duplicate nodes, go to Mesh, Node, Modify, Merge. Select all the nodes, give a tolerance value of 0.001 and click Apply. It will highlight all the nodes which are going to be merged. Click Yes. Again go to View, Free Edge. There will be no free edge at the center. All the duplicate nodes at the center will be merged. Now go to View, untick Free Edges. Now you have to create the rigid links. For that, you need a node at the center which will act as the master node. Go to Mesh, Node, Create Between. Select two nodes between which the node should be created. Click Apply. A node will be created at the center. Now you have to create the rigid links. Go to Front View. Click Fit to View. Go to Mesh, Element, Create, Rigid Links, Add. A rigid link parameter box will come. There are slave nodes and master nodes. For selecting the slave nodes around the circumference of the internal surface, select Circular Selection from Selection. While selecting, all nodes on the internal surface will be selected. You need only the nodes on top of the cylinder. For erasing the unwanted nodes from the node ID list, pick Rectangular Selection tool again. Shift plus Select will remove the unwanted node IDs from the slave node list. Don't forget to remove the master node from the slave node list. Select Shift. Click Shift and select the node. It will remove the master node from the slave node list. Pick the master node as the center node. Degrees of freedom of the slave nodes 1, 2, 3, 4, 5, 6, which means all 6 degrees of freedom of the slave nodes will be arrested. Click Apply. The rigid links will be created. If you go to Edit, click on Rigid Link Set 1, it will highlight the rigid link. Now go to Load Displacement Boundary Condition, select the center node, arrest all degrees of freedom. All degrees of freedom of the master node or center node will be arrested. Click Fill View, it will highlight the elements. Now you have to apply the symmetric boundary condition. For that, go to Lower Displacement Boundary Condition, pick isoface and click on the face to select all the nodes on that face and arrest only UY degree of freedom. Go to Property, Function, Real Table. Here you are going to enter the frequency versus acceleration data, that is the shock data. Select the corresponding file for shock data which is already saved in some folder. It will be called to the table data. Here X refers to frequency. Click OK. The table will be added. Now go to Analysis, Analysis Type. Set Analysis Type as Shock. Click Apply. Go to Analysis, Analysis option. Click Apply. Go to Analysis. Shock Response, General Add. Either number of modes or frequency range can be selected. Select number of modes and enter the eigendata as 2. Go to shock data. Enter F1, which is the table we have defined already, in shock data X direction. Shock will be applied in X direction. Click Apply. Now save the model. Run solver. Confirm yes. It will show an error message that material 0 is not defined, which means we haven't defined the material yet. For that, go to Property, Material, Isotropic Add. Select all the elements. Enter the material data as modulus of elasticity 200,000, Poisson's ratio 0.3, and mass density as 7.80 minus 9. Click OK. Material will be assigned. Now again save. Run solver. Confirm yes. It will show finished successfully. Go to Post, View Results. Select acceleration. Pick any particular node. Click Apply. It will show the acceleration for that node in Tx, Ty, Tz directions and the resultant of acceleration also.